Isaac Newton was not just a scientist, he was the architect of the modern universe. Long before space travel, computers, or electricity, Newton uncovered the hidden rules that govern motion, force, and gravity. From falling apples to orbiting planets, he revealed that nature follows precise mathematical laws. Even today, engineers, scientists, and astronauts rely on Newton's ideas, often without realizing it. And yet, centuries later, many people still say his name wrong. Isaac Newton was an English mathematician, physicist, and astronomer whose work laid the foundation for classical physics. He unified motion, gravity, and mechanics into a single framework that explained of earthly and celestial movement. For more than 300 years, Newton's laws defined humanity's understanding of the physical world. His influence extended beyond science into philosophy, engineering, navigation, and even economics. Few individuals in history have shaped human knowledge as profoundly as Isaac Newton. Isaac Newton was born in 1643 in Woolsthorpe, England, prematurely and fragile. His father died before his birth, and his early childhood was marked by separation and emotional isolation. Newton grew into a quiet, observant child with a fascination for mechanical devices and natural phenomena. He preferred solitude and deep thinking over social interaction, a trait that would later define his scientific life. These early years shaped Newton's intense independence and focus. Newton studied at Trinity College, Cambridge, where he encountered mathematics and natural philosophy. Dissatisfied with traditional teaching, he pursued independent study, mastering advanced mathematics on his own. He studied the works of Galileo, Descartes, and Kepler, absorbing their ideas while identifying their limitations. Rather than following a mentor, Newton became his own guide, developing new mathematical tools to describe nature more precisely. This independence allowed him to go far beyond the scientific thinking of his time. In 1665, a deadly plague forced Cambridge University to close. Newton returned home and entered what is now known as his annus mirabilis, the miracle years. During isolation, he developed calculus, formulated the laws of motion, and began his theory of gravity. Free from academic constraints, Newton made discoveries that would normally take lifetimes, all before the age of 25. This period marked the birth of modern physics. Newton's greatest contribution was his ability to unify nature under mathematical laws. His three laws of motion describe how objects respond to forces, forming the backbone of classical mechanics. These laws explain everything from walking and driving to the motion of planets and spacecraft. Newton's law of universal gravitation revealed that gravity acts between all objects with mass. This single insight explained falling objects on Earth and the motion of the moon and planets in the same framework. For the first time, the universe operated under one set of rules. Newton also developed calculus, a mathematical language capable of describing continuous change. Although controversial, calculus became essential for physics, engineering, and later technological innovation. In optics, Newton demonstrated that white light is composed of multiple colors. His prism experiments revolutionized the study of light and vision, influencing telescopes and microscopes. In 1687, Newton published Principia Mathematica, one of the most important scientific books ever written. It formalized his theories and established mathematics as the language of science. Despite his genius, Newton was deeply private and often confrontational. He engaged in intense disputes with other scientists, particularly with Gottfried Wilhelm Leibniz over calculus. Newton fiercely protected his ideas and struggled with criticism. These conflicts revealed a complex personality, brilliant, sensitive, and often isolated. His human flaws remind us that even the greatest minds wrestle with ego and insecurity. Isaac Newton's work defined science for centuries. Engineers used his laws to build machines, bridges, and transportation systems. Astronomers relied on his equations to predict planetary motion. Even Albert Einstein acknowledged Newton as the foundation upon which relativity was built. Newton transformed science from observation into prediction, forever changing how humanity understands the universe. Isaac Newton showed the world that the universe is not ruled by chaos, but by discoverable laws. Through patience, solitude, and relentless curiosity, he unlocked principles that still shape modern science, engineering, and space exploration. His legacy reminds us that careful thinking can change how humanity understands reality itself. If you enjoyed this documentary, subscribe to Say It Right for more stories about the great minds who shaped our world. Learn their ideas, understand their impact, and say their names right.